Have you ever really, and I mean really, looked at a brick? They're everywhere. They hold up our homes, our schools, our cities. They seem so simple, right? So common. But packed inside that familiar little block is this incredible story that spans thousands of years of human ingenuity. Today, we're going to unpack that story. Okay, let's just jump right in with a question for you. Think about those three things for a second. You've got an ancient wonder of the world, snaking across entire mountains. You've got a masterpiece of Roman engineering that brought water to cities from miles away. And then you've got the fire station probably just down the street. So what on earth is the connection?
Yep, it's the simple, totally unassuming brick. This one material is the thread that connects some of humanity's most ambitious projects across different continents and different centuries. It's really a testament to a piece of technology that was so effective, its core ideas have barely had to change at all.
So the story kicks off thousands and thousands of years ago in places like Mesopotamia and the Indus Valley. That's where early civilizations first figured out they could mold wet mud into blocks and just let the sun bake them hard. But the real game changer, that was the invention of the kiln. Firing the clay with intense heat completely transformed it, making brick strong, durable, and water-resistant. The Romans took that idea and just ran with it, building these massive cities and aqueducts that, are still standing today. It's proof of just how long-lasting a good brick can be.
Okay, so how do we get from a pile of dirt to a perfectly formed building block? Let's follow the modern journey of a brick all the way from the earth it comes from to the fire that gives it its strength.
It all starts in a quarry, where clay gets dug right out of the earth. That raw clay is then mixed up and shaped into what are called green bricks. Now, they're not ready yet. They're still soft. They have to be dried out really slowly so they don't crack. And only then do they get to the final transformative step, getting fired in a massive kiln, which hardens them into the finished product we all recognize.
Now, when it comes to actually forming the brick, you've got two main methods. There's the traditional soft mud process, which is where wet clay gets pressed into molds. This gives each brick a unique, kind of handmade character. But the most common way today is called stiff mud extrusion. A firmer clay mix is pushed through a die, think of it like pasta dough, and then sliced by wires. This is how you get those super sharp, uniform bricks you see in most modern construction. After the drying comes the trial by fire. And I mean, we are talking serious heat. Bricks are cooked in kilns at temperatures up to 1200 degrees Celsius. That's over 2000 degrees Fahrenheit. This intense heat is what fundamentally changes the clay from something soft and fragile into something incredibly durable.
And at that insane temperature, a really crucial process happens. It's called vitrification. The clay particles literally start to melt and fuse together, and they form this glassy internal bond. This right here is the source of a brick's superpowers, its immense strength, its durability, and its ability to resist water.
And you know what else that firing process does? It determines the brick's final color. The classic red we all picture, that comes from a high iron content in the clay. But that is just the beginning.
By switching up the type of clay or just tweaking the kiln's temperature, you can get a whole spectrum of these beautiful earthy tones, like buff or cream.
If you push that temperature even higher, you can start creating these deeper, richer colors, including some really cool dark purples.
And by controlling the amount of oxygen in the kiln, you can even make very dark blues and blacks. See, in a fire with lots of oxygen, the iron oxidizes and turns red. But, and this is the cool part, if you starve the fire of oxygen, you create what's called a reducing atmosphere, and that can turn the very same iron into deep purples and blacks. The color isn't a dye, it's a permanent chemical change that's literally baked into the material itself.
So, we've made our brick, but what makes it such a phenomenal building material? Let's take a look at what it actually does out in the world. Well, it all comes down to a few key built-in advantages. Bricks have incredible compressive strength, which means they can support enormous weight. They're naturally fire-resistant. They have excellent thermal mass. They act like a heat battery, absorbing warmth during the day and slowly releasing it at night. And in an age of climate change, that means buildings that need less energy for heating and cooling. It's a passive superpower that's more relevant than ever. On top of all that, they're durable enough to last for centuries and are great at blocking sound. So, how are they used in a wall? Historically, buildings were made with these thick structural brick walls. Multiple layers, they're called wides, would carry the entire weight of the building. Today, though, it's much more common to see brick used as a veneer or cladding. This is a single outer layer that gives you that classic look and protects from the weather, while a modern wood or steel frame on the inside is doing all the heavy lifting.
But the brick story isn't just about the past, not at all. The industry is constantly evolving. So, in our final section, let's look at how this humble brick is being reimagined for a more sustainable future.
This quote right here really just nails it. A brick isn't just one thing. It's this link between the earth it came from, the craft that goes into making it, the engineering of how we use it, and this growing awareness of its environmental footprint.
And the industry is really addressing that footprint head-on. Instead of just using high-energy kilns, modern factories are recycling waste heat and using cleaner fuels. Instead of using 100% virgin clay, they're now incorporating waste materials like fly ash. And, crucially, at the end of a building's life, bricks are no longer just demolition waste destined for a landfill.
Bricks are getting a second life. And this isn't just recycling. It's a true circular economy taking shape. Old bricks can be reclaimed, and they're actually valued for their unique historical character. They can be crushed up into aggregate for roads. Innovators are even developing low-carbon bricks that harden using chemical processes instead of all that intense heat. Even the land is being renewed, with old clay pits being restored into parks and wildlife habitats.
So the next time you're walking down the street, just for a moment, stop and look at that brick wall. You're not just seeing a building material. You're seeing a direct link to our earliest civilizations, a marvel of chemistry and heat, and a technology that is still evolving right now. You're seeing a library of human ingenuity, built one humble, mighty brick at a time.